This should be a fairly straightforward lesson. We're still going to be using the compound interest formula, a equals p times 1 plus I to the power of n, but we're going to be using it in a different way. Now, that formula tells us the future value of our investment. We use a for the future value. But what if we want to kind of go backwards? What if we want to know what principal was needed in order to receive a certain future value? So for example, if I knew that I wanted to buy a car for, let's say, $20,000 5 years from now, how much would I have to invest right now in order to get there? That's the sort of question we're going to be solving today. Now, we'll be using the same compound interest formula, but all we want to do is isolate for p. So if I write it out, we got a equals p times 1 plus I to the power of n. I just want to isolate that p, so I would do that by dividing both sides by 1 plus I to the power of n. And that's it. That's our formula right there. So I'm going to be erasing this all beside the p here. So this is our formula for p, a divided by 1 plus I to the power of n. Now we can write this in a different way just to kind of simplify it a little bit. And this is something that I'm going to be using. Instead of dividing by 1 plus I to the power of n, if you remember our work on exponents, we could actually write this as 1 plus I to the power of negative n. Okay, so a negative exponent means that we are dividing by that base with that exponent, so it is equivalent. This is the formula I'm going to be using. So p is still the principal, or the present value we wish to calculate. A is the future value, how much we need to have in the future. I is still the interest rate per compounding period, so we still have to compound the interest, and n is still the number of compounding periods. So this first question, a cruise you want to take 1 year from now will cost approximately $1,500. How much will you have to invest at 9% compounded monthly to have enough money? So again, you're going to have to be able to recognize from the question that $1,500 does not represent the present value. It represents the future value. You need to have $1,500 in 1 year. Now, our interest rate is 9%, 0.09, but divide by 12 because it's monthly. So the I value is 0.0075. Now, n is the number of times you earn interest. Now, it is 1 year from now, and it's compounded monthly. So you'll be earning interest 12 times in total. So when I put my formula together, P equals, we got 1,500 times 1.0075. So this looks pretty much the same, but the difference now is going to be to the power of negative 12. This will give us an answer of, we got $1,371.36. So that's how much you would have to invest in order to have $1,500 by the end of the year. Now this makes sense because obviously if you start with a smaller amount of money, it's going to grow into something bigger. It's going to grow into the larger sum of money. So if you forgot that negative on the exponent, you would actually get a larger answer than what you're supposed to end up with, 1,500, and that's a way you can tell if you're correct or not. Now I've already filled out the next two solutions because we're just, again, doing the same idea as compound interest but working backwards. Now, a high school student will be graduating in 2 years, and she estimates that she will need $10,000 for her first year expenses. So that $10,000 represents her future amount A. That's what she needs to have. Now, the interest rate is 5%, 0.05 divided by 4, because it's compounded quarterly, 4 times a year. And it is in 2 years that she needs that money, but because it's compounded quarterly, she's going to be earning interest 8 times in total. So again, when you put together the formula, the exponent is negative 8 because we're working backwards from 10,000. $9,053.98 approximately is what you would have to invest right now in order to have $10,000 in 2 years. Now, the last question, remember that interest can work against you as well. So if you borrow money to buy a car, you will be charged interest. So this interest rate being charged is 14% compounded semi-annually, and you paid back a total of $29,507.27 after 5 years. So that $29,000 was after the 5 years of the loan. That's how much you paid back in total. So we want to figure out how much did you originally borrow. So again, that's your final amount. Interest rate is 14% divided by 2, 0.07. And the end value is 5 years times 2, because semi-annual means twice per year, is 10. And here we go. The price was about $15,000. Now, the trickiest part about compound interest is you're going to have to be able to tell what is a future value question and what is a present value question. So it's very important that you look at whatever the dollar amount is that you're given, try to figure out, is that what's being invested or is that what you're ending up with?